Okay class, today I'm going to give you some helpful tips for your soil lab that you're going to be doing on your own. Today here I'm at the Chino Valley Agribusiness Campus. This is our research garden. There's not a lot going on here right now. This is the time of year where we have a cover crop down. The cover crop's starting to grow. It'll start to pick up speed here as the season wears on and it gets a little bit warmer. But this is the time of year where you start thinking about soil and building soil and getting prepared for plant growth. The same thing you guys are thinking about as far as texture goes when deciding what kind of soil you have. And so I want to be clear, the things we're looking for in the lab that you're doing on your own, you're going to be looking at sedimentation, you're going to be looking at pore space, and you're going to be using the field method, or field method, in quotations, field method, for determining the texture of the soils. Texture is something that is very hard to change. Short of adding organic material, that's typically the way that's done. There's three components: sand, silt, and clay in every soil. And I'm going to help you triangulate and figure out those three different components in soil you have currently, and then the practice of how to amend those soils. You don't want to just take a sample from one spot. If this is my area, I want to take multiple samples around the place to kind of make that uniform and take out any variability this spot compared to that spot, especially if it's raw ground. If it's soil that's been used, we've had this research garden going here and amended for about 3 years now, and so it's pretty homogeneous throughout, but I'm still going to take samples from different places. You want to take your sample about 6 inches down. This is nice friable soil, 6 inches down, and you want a good example of that soil down throughout. Now I've collected 3 of those scoops. For the case of our bag, for the case of our soils class, a gallon sandwich bag would probably be enough. A gallon of material is more than enough soil that you need. So I took down to 6 inches in depth, and I did this multiple times. I got my soil. Now let's go to a nice place where I can analyze the soil. Okay, now I have my soils lab that I printed out, and the first thing it talks about doing is sedimentation. So this is very simple. You have these materials at home. I just use a glass jar with a lid, any container that you can add soil and water and close up and shake is a container that'll work for you. As far as the volume goes, you want just enough so you'll be able to read those percentages. So in my case here, I'm taking our soil that we just collected, our homogeneous sample from around our area. I'll add about 50% of the soil here. I'm using about this much. This part is not critical for the measurement. And then I need enough water to put this into suspension. So I'll probably add water until about there. It gives me enough water space to get this agitated and stirred up. Again, I didn't measure that. I don't care on this part, sedimentation. We're just going to measure the depth of the different soils, separates, and we're going to ignore the water that's in there. So again, just enough water to get this thing violently stirred up. I'm putting the lid on there. If I was doing this outside, I could put my hand over it and shake it up. It doesn't need to be a fancy lid. So now I'm making sure all of this gets into suspension. Okay? It's like a mixed drink. Okay, it's all in suspension, it's all stirred up. Now I'm going to sit this. This is why we start with this one. I'm going to sit it, leave it somewhere, don't touch it, let sedimentation occur. Okay, now we are going to look at pore space testing. So what I've done here is I've put 100 milliliters of soil into a beaker, and I've put 100 milliliters of water into a graduated cylinder. Okay, you may be saying, I don't have access to these kind of measuring devices. So let me tell you what I can do to make it super easy. If you are close to the Chino campus or have other classes in the Chino campus, these two measuring devices will be in the back of the greenhouse. And if you are in the Verde, near the Verde, you can use these as well. However, these are not necessary. You can use tablespoons, you could use teaspoons, you could use ounces, you could use any device you have for measuring. All you're determining is how much water fills the available pore space here, and then you do a calculation. Okay, the thing to keep certain here is the percentage of moisture in your soil is super important to start with. So you want to start with a dried soil. Oftentimes these are oven dried till they've reached the point that they're completely dry. We're adding moisture into the soil to determine pore space. If there's already moisture in the pore space, your calculation is flawed from the start. Don't stress, because we're practicing these calculations. Okay, so the way I'm doing this in the 100 to 100 measurement is I'm going to tip this to the side a little bit. I'm slowly adding water until all of the pore space is filled. I'll know when all the pore space is filled because free water will be standing. And so I'm just slowly adding, and then I'm looking. All the water is absorbing into the soil. All the water is absorbing into the soil. I'm going very slow because the second I have standing water is the moment that all of the pore space has been reached to complete saturated capacity. Okay, we're getting close. And you don't want to compact the soil that's in here. Okay, we're starting to see water soaking in. This is probably going to be close. All of the water has soaked in, filled the pore space. If I added any more water, then there'd be standing water on top of this soil sample. So do that for your 3 soil samples and you'll come up with a percentage. I had 76 mils left over. So that means this sample absorbed 24 mils of water. And let's do that math. So to be exactly precise, I started with 100 mils of water. I had 76 mils left. I am left with 24 milliliters, which would be 24% pore space. It took 24 mils of water to fill that pore space, so 24% pore space. So whatever measurement you use, you can calculate the percentage off of that. A sandy soil will have a higher percentage of pore space, and a clayey soil will have a lower percentage of pore space. Silt will fall somewhere in the middle. Remember to dry your soil, and remember to repeat this 3 times for your different soils. Lastly, you're doing feel or field classifying. And so this method, you take a soil in your hand, you add water. I have a fancy little squeeze bottle that I'm adding here, but in this case, I'm excessively wetting a small pinch in my hand, and I'm feeling it, and I'm feeling for 3 things. Coarseness, which would be sand, stickiness, which would be clay, or slickness, which would be silt. And so I'm feeling for that. This is a very low-tech method of getting your hands in the dirt. The next thing I'm doing is I'm adding moisture here to my big piece. I'm making a ball, and I'm determining whether this ball can remain a ball in my hand. Again, this is testing for clay, and I feel stickiness in this soil. So yes, this soil is forming a ball. It's also called ribbon. Making a ribbon, I'll show you an example of making a ribbon. Okay, you put it between your thumb and forefinger and you start to push. Do you see this soil sticking together? you measure the length of the ribbon before it falls. That is a ribbon. You could also have this soil, I consider it like a soil snake. If your soil is holding together and can do this, that's ribbon. If I was to push this out, push this out, push this out, I've made a ribbon. This soil has a high percentage of clay. If it doesn't do this, it's got a high percentage of sand or silt. And so you're going through the process of feeling your soil to determine the components of sand, silt, and clay. There's a process that dead ends at each one and gives you the answer of what your soil is. This takes lots of technique and lots of practice, but I know enough to say, boy, this soil has a big percentage of clay in it. Okay? That's how easy feel method is. The other thing you're going to do is look at the soil textural triangle that I've provided for you, and in that textural triangle you're going to be working the components to find out how much sand, silt, and clay so you can classify those soils. Now, not all these methods on their own are perfect, and so what you do at the end is you come back to your sedimentation and you look for lines. Most soils have a percentage of sand, silt, and clay. Sand will be at the bottom with the biggest, grainiest size pieces. It'll feel rough and coarse in your hand. The next intermediate will be silt, and then whatever's on the top will be clay. And so you're looking at this, and then here's your water, and then any organic material that was in your soil is floating on the top. So you look at this, and you can even put a ruler next to this, and you start to assign percentages. I see a very distinct line here between what looks like sand and what looks like clay. I'll have to let this settle out a little bit more. I knew that my soil had a lot of clay in it because I can do this. I can ribbon quite a ways. And so this, feeling it, helps me decide what these layers are here. I can see the coarseness and the graininess down below here, so I'm going to say that's sand. I see a small fine layer that might be silt, and I see a big layer of clay, which then helps me to decide what I saw here and make percentages and make decisions on the textural triangle, where the pore space then also helps me to understand. 24% pore space is not very much, and so this soil, it's telling me this is a highly clay soil, and so then I'll use the three of these things to make a decision about my soil. Those of you interested in continued management of your soil beyond just knowing the texture of your soil could send out soils for soil sampling. There you can get information on nutrients. There you can get an exact percentages of sand, silt, and clay. But as far as manipulating your soils, when you find out what the texture is, the good news is if you have a sandy soil, extremely sandy soil, the best thing you can do is add organic material. Organic material, mulches, compost, manures, peat moss. Organic materials will help increase the moisture holding capacity so your soil doesn't drain so fast. Okay, to the other extreme, you have a heavy clay soil and you want to loosen it up and lighten it up. Well, you don't bring in truckloads and truckloads of sand because that's not cost effective. The thing you do is add organic material. Mulches and manures and compost. Adding organic material to heavy clay soil loosens it up and lightens it up. So silt would be perfectly in between. The best soils are a mixture of sand, silt, and clay. Those are a lot of our loamy soils, and so if you're not there with a loamy soil, organic material is the key. I hope you enjoy this lab. I hope you learn from the three soils that you practice with. Be close on your calculations, but keep in mind, I'm not going to be telling you, you said 24% pore space, I calculated it at 23%. This is for you to practice getting your hands in the soil and feeling it out, and then using the three components to make a decision. Okay, good luck.